switch to PC, and then router to switch also we use some straight cable. So and then we can assign the IP addresses. So what I'm going to do is I'm going to make one basic setup lab in this scenario where I'm going to connect some 4 computers in the LAN, and I want to make sure that these 4 devices should be able to communicate with each other. Okay, and also I'm going to configure some IP addressing on them. Let's say the IP addressing will be, I'll be using 192.168.1.1 network, where I'll be using 1.1 here, 1.2, 1.3, 1.4. So the X represents these numbers on all the PCs. Anyway, we are going to connect the routers later on when we get into some more advanced topics. Okay, and then finally what we are going to do is we'll ensure that this PC 1.1 should be able to communicate with 1.2, 1.3, 1.4, the remaining PCs, and we are going to test the basic connectivity by using ping commands. Okay, so to implement this lab, I can either have some physical switch, and then I can have some 4 different computers connected in the LAN through some straight cables, and then we are going to assign some IP addresses. But here I'm going to show you up everything on a simulation tool and a packet tracer. So using this packet tracer, it's a Cisco program, Cisco packet tracer, which will allow you to simulate the real routers and the switches of Cisco devices. Okay, so probably even if I have some real devices, even though they might be connected, so it's not easy for me to present out here. So you need to assume that we got some real devices connected. So I'm going to simulate the labs by using this simulation tool. So I got a packet tracer here, Cisco packet tracer program. Okay, so it's a very good tool for simulating your labs. So it's an alternative to your real devices, and it's also an academy. It's a tool which is used in Cisco Network Academy for major trainings. So I'm going to show you some of the basic things, how it's going to work here. So if you just come down in the bottom here, you'll find some routers here. You can see some routers here, and then you see some switches. If you click on the switches, you'll find some different models of switches, and if you click on the router, you'll find some different models of Cisco devices. So right now I'll get into more in detail on the different models of Cisco routers in our next sections. We can also have some hubs, some wireless devices, and some PCs here. So it's like a simulation of your real devices. So I need one switch. So to get one switch, you just need to drag and drop a switch here. I can delete this device here. So I need one switch here. So I'm going to connect one switch, and if you want some computers on the left side, you can see computers here. You can drag and drop some PCs, computers, and even you can drag and drop some server computers like this. So this is like, virtually we have some devices in the LAN, and I got a switch from where I'm going to provide the connectivity. Now to provide the connectivity from switch to PC, we need some straight cable, right? So probably to get some cables here, you need to click on this button here. On the left side, you can see this cable, console cable, straight cable, crossover cable. So right now we either use a straight cable or cross cable. So at this point we use the straight cable. So select this cable and then click on the switch. It's going to show up which port you want to connect. Any port we can use. I'm using F0/1, and here you'll find 2 ports. RS232 is actually a COM port, which we'll be discussing in our next sections. 9-pin port. So right now we are using fast Ethernet port. Again, connect a straight cable from the PC, fast Ethernet to any port on the switch. Again, a straight cable connecting from fast Ethernet to any port on the switch, and again a straight cable connecting fast Ethernet to any port on the switch. So in case if you use a wrong cable here, it's not going to give any message here, but probably it will not allow the communication process to happen. So we need to ensure that we are using a right cable for the right device connectivity. Now the next thing is how to assign the IP addresses. So this is what we discussed. We are going to connect some 4 computers in the LAN by using a centralized device called switch, and we are going to assume that this switch is having all the ports and they all are connected in the LAN. Now the next thing, we need to assign some IP addressing on all the PCs by using some 192.168.1. network. So probably I'll be using 192.168.1. network here with 1.1 here, 2 here, 3 here, 4 here. So in general, on a normal computers, we need to go to my network places. We need to open up my network places from the control panel, or I can open directly here. I can change the adapter settings, and then I can go to my local area connection properties, the cable, the port which I'm connecting in my LAN. I'm assuming that this is what I'm connecting here, but it's not in the packet tracer. It's on the real devices. We do like this, and then we need to select TCP/IP v4 properties, and then we can assign the IP address of 192.168.1.1. So I'm going to assign the IP address of 192.168.1.1 and the subnet mask of the default subnet mask. So if you want to use any customized subnet like what we have learned in the subnetting, we can do that. And the default gateway is actually the address of the router, which we'll see in our next section more in detail. Now if you're doing on the real devices, this is how we do. But in a packet tracer, when you're simulating your labs, to do the same thing, we just go to the computer, click on the computer. It's open up another window here. Go to desktop here, and then here you'll find some IP configuration. So if you want to go to the command prompt in the real devices, we go to here and type CMD, right? This is how we get into this command prompt for testing the ping commands or trace commands here. But on the packet tracer, if you want to go, we have to go to this here. We click on this. Okay. So right now, first we'll assign the IP addresses of the computers. So for the first computer, I'm going to assign the IP address of 192.168.1.1. And for the next computer, I'm going to assign the IP address of 192.168.1.2. And for the third computer, I'm going to assign the IP address of 192.168.1.3. Ensure that they are on the same network, because in order to communicate, they must be physically same as well as they must be logically in the same networks. So I'm going to use 192.168.1.4. Done. So once we do the basic connectivity, what we did up to now, we did some basic connectivity from switch to the PC, and then we have assigned some IP address of 192.168.1.1, 1.2, 1.3, 1.4. Now once we do this, the next step is to test the connectivity. Now to test the connectivity, you can see I'm going to this computer here, first computer, on the command prompt. We can go to the command prompt here, and then the first command, this is like a similar command prompt what you find in your computers. We need to say ipconfig. In that ipconfig, you can verify what is your IP address, what you have assigned, and the subnet mask. Default gateway, we didn't give anything, so it will be all zeros. Probably we'll see more in detail on the default gateway in the later on sessions. So I want to test the connectivity. So if you remember, in the basic classes, we have discussed that ping command is used to test the basic connectivity. So whenever you go to this 1.1 computer, and if you give this command ping to that particular 192.168.1.2, it's going to generate some echo request messages, and that particular device is going to send an echo reply messages. Okay, so it's going to confirm whether there is a connectivity or not. So the reply will go to the request, will go to the switch, and switch will reply back to the computer, that is 1.2, and that's how it works. And internally inside the switch, they identify based on the MAC addresses. Now this is something we'll be getting into more in detail when we start the switching topics. So I'm not getting into more in detail of the basic switching concepts. So I'm just connecting a switch, and then we are doing the testing. But internally there is something called ARP, finding the MAC address, MAC table. More on that, we'll be getting into that in our switching topics. So as of now, we just give a ping command, and you can see the reply is coming, and which is going to tell that this particular device is replying from 1.2. Let me try to communicate with 192.168.1.3, the third computer, and also I'm trying to ping to the fourth computer, so you can see the reply is coming. Now whenever you're doing some troubleshooting between these devices, in case if 192.168.1.1 is not able to communicate with 192.168.1.3, check the cables, check the connection on the cables, and then check the ports on which interface you are connecting. So we need to ensure that the local area connection must be okay. So this connectivity should be okay, and the major thing is they should be on the same network. Remember that same network means they should be physically on the same network, as well as they're on the same LAN, and the network ID, network portion has to be same. You can see this is 192.168.1.1 and the other address is 192.168.1.4. They should be on the same network portions, and then they should be on the same LAN. That's very important. Okay, so and then we need to check the connectivity as well. Okay, connectivity from the router, from the switch to PC, or the switch to computer here, whatever it is, and the connection on the ports. And if you're using wrong cable also, you need to check the cable. There might be some cabling issues, or try connecting some other cable. If you realize that there is some port issue, you can try connecting to another port and you can verify. So that's how we do the basic connectivity in our LAN, and also the basic troubleshooting as well.